Okay, so the highest common factor of 52 and 24. So let's try that. Let's do our prime factorization tree. So 2 times 26 will give us 52. So 2 is a prime number, circle it. 2 times 13. So 2 is a prime number, 13 is a prime number. We're finished with 52. Now we know we're finished because 2 times 2 equals 4, right? And then 4 times 13 equals 52. So that's complete, and that is correct. 24 can be done by, let's say, 3 times 8. 3 is a prime number. 8 is 2 times 4, right? So 2 is a prime number. 4 is 2 times 2. So those are all prime numbers. Let's do some cancelling out. So that is a 2 here, cancels that 2 out, right? So that's out. This 2 cancels out that 2, right? And we're left with 13 times 3 times 2. So 13 times 3 is 39 times 2 is 78. Finding the highest common factor. So we're going to find the highest common factor of 24 and 32. Now just a quick note, highest common factor is also commonly referred to as the greatest common factor. So HCF, GCF, it's the same thing. So the way we're going to do this is by using prime factorization, and we're going to essentially draw a little bit of a tree. So this is how we do it. We say what times what will equal 24. Now because 24 is a nice even number, we can just halve it. So 2 times something is going to be 24, and that something is 12. Whenever we do this step, the very next thing you do is look to see if any of the factors that you've identified are prime. So in this case, 2 is a prime number because it can only be divided by 2 and 1. So 1 and itself in order to get a whole number answer. So 2 is a prime number. We circle any prime number we come up with. In the case of 12, it's not a prime number. I can take that even further. I can reduce it to 2 times 6, because 2 times 6 is 12. Again, we have a 2, and that's a prime number. 6 is not a prime number. We can keep going with 6. 2 times 3. So 2 is a prime number, and 3 is a prime number. And we've reached the end of our prime factorization tree. 24, that is. Let's have a look at 32. Let's do the same approach because it's nice and easy. We don't have to think too hard. It's an even number, so 2 times 16. So 2 is a prime number, 16 is not. 2 times 8 gives us 16, so 2 is a prime number, 8 is not. 2 times 4, so 2 is a prime number, 4 is not. 4 is a 2 and a 2. So what we now look for is any of the factors that are both present for 24, any of the prime factors that are in 24 and also in 32. So in this case, we've got a 2 and a 2. So let's write that. We've got 2 times, what else have we got? We've got a 2 here and another 2 here. So that's another 2 we can add or put into this new equation. We have a 2 here. Are there any more 2's? Yes. So, yep. That's another 2. And we've got a 3 here. There are no 3's there. There are no 2's on this side, so we're finished. We've reached the end. So the common prime factors were 2, right? Here's one of them. Here's the second one. And here's the third one. And so we just multiply these. 2 times 2 times 2. 2 times 2 is 4 times 2 is 8. So I now know that the highest common factor is 8. 8 goes into 24, so that goes into it 3 times, and 8 goes into 32 4 times, so 8 does go into both of them. It is the highest, it's the greatest number, it's the greatest factor that can go into 24 and 32. So